Good afternoon, and welcome to the introductory session to Amazon Redshift. My name is Pawan Pothukuchi. I lead the product team for Redshift, and I'm glad to have with me Nam Nguyen from RetailMeNot, who is going to talk about their journey with Redshift. So in today's session, we're going to talk about what Redshift is and why you would want to consider using it. We'll talk about some of the key features of Redshift and their benefits. We'll talk about how customers are using Amazon Redshift. And of course, we'll have Nam talk about how Redshift fits into their analytical platform at RetailMeNot. And we'll have some time for questions. So this is the ever-changing snapshot of the AWS Big Data portfolio. So you can bring large amounts of data into AWS using Direct Connect. We have import, export, and as of today morning, Snowball. We have Kinesis, through which you can stream data from hundreds of thousands of data producers and process them across multiple services within AWS. And of course, there's another service there that got added, Kinesis Firehose. On the storage side, depending on the data format, you can store just about anything in S3. You can, if the data has relational semantics, you can use Amazon Aurora for that. For key value data, we have DynamoDB. For lifecycle policies and moving data to a lower storage, low-cost storage system, you can do that through Glacier from Amazon S3. For text search and indexing, we have Cloud Search that can be utilized. Once you store all of this data, we have a set of services through which you can analyze them. We have Amazon EMR that can be used to process unstructured data very quickly through Hadoop. Once you process that data, you can bring into Amazon Redshift for quick SQL access. So we have machine learning, through which you can run predictive analytics on data sitting in Amazon Redshift. We have a data orchestration layer called Data Pipeline that can help you move data across these various services and schedule jobs. Again, this picture got a little bit bigger as of today morning. On the analytics side, we have QuickSight. On the orchestration side, we have the data migration service that can help you move data across database engines. So one of the occupational hazards of working for AWS is our slides tend to get stale very quickly. So what is Redshift? In simple terms, Redshift is data warehousing made fast, simple, and very cost-effective. Redshift is a SQL-based relational data warehouse. It's based on a massively parallel processing architecture and uses columnar storage. It's an order of magnitude faster than a lot of the comparable row stores out there. It's very easy to use. You can provision hundreds of gigabytes or hundreds of terabytes within under 3 minutes. You can scale, you can add capacity, you can remove capacity through a few clicks on the management console. It's a managed service in that we manage backups. We make recovery very easy. We manage patching. We manage a bunch of other aspects around disaster recovery and make it very easy for you to set it up. It's very cost effective. Like I described earlier, it's an order of magnitude cheaper than a lot of other data warehousing solutions available in the market. So the traditional view of data warehousing, and if you've been to Andy's keynote, it sort of reflects some of the points that he has been touching on. It has largely centered around multi-year deployments, multi-year deals, multi-million-dollar deals, and multi-year commitments. So all of this means that data warehousing has largely been in the realm of usage within the top 1,000 to 2,000 global enterprises. And it has largely been sold to central IT teams within enterprises. We believe that this is a very narrow view. As a lot of you in this audience today can vouch, small companies have big data too. Especially in the last 5 years or so, with the proliferation of mobile, ad tech, gaming, social, and IoT, this is increasingly the case. Even within enterprises, long deployment cycles, high operational complexity, and a lot of costs that are involved across both provisioning, managing, and procuring warehouse infrastructure means that departmental groups within enterprises are not able to move as fast as they want to on projects. This leads to what we believe is a lot of dark data, and this is an analysis from one of the analyst companies that shows more than an exabyte of dark data sitting in enterprise data stores. So our view of data warehousing is more inclusive. So we believe that Redshift is appealing to enterprises because of the cost advantage. It's also appealing because it's extremely easy to provision it. And so central IT teams can provision data warehouse infrastructure very quickly and scale it very easily. Increasingly, we're also seeing central IT setting guidelines and letting the departmental groups go build their own infrastructure as they see fit. Redshift also enables high DBA productivity given the managed aspect of the service. We're also seeing, of course, a lot of big data companies leveraging Redshift very efficiently. And the key selling point for big data companies is Redshift is an order of magnitude faster than Hadoop, SQL on Hadoop. Analysts within companies don't need to learn scripting, don't need to learn programming. It's a standard SQL interface that can go and that they can go and execute queries against. Redshift also ties pretty well into a lot of other technologies that companies with big data use. It ties very well with Hadoop. You can run your ETL jobs or MapReduce jobs on Hadoop. You can bring the data into Redshift through a copy command that is available on the database directly. You can parallelly load data from services like EMR. You can leverage data science technologies like machine learning on top of Redshift. We also are increasingly seeing a lot of SaaS companies leveraging Redshift. And the key selling point for them is they want to provide more analytical horsepower to their customers and don't want to wait until all the data is processed. They want to show the analytical capabilities right within the process flows of their applications. They also like the fact that they can pay on demand, they can grow on demand easily with Redshift. And the managed nature with availability managed for them, DR managed for them is also appealing. So this sort of a view is leading to a pretty broad growth for Redshift across a variety of verticals and variety of customer segments. So we have companies like NASDAQ, which is very security focused, a traditional enterprise that is using Redshift to load about 5 to 8 billion rows of data per day, per trading day, and analyze orders, quotes, and trades. We have Yelp using Redshift for analyzing ad campaign performance as well as understanding how their end users are using their mobile app features. So you have companies like Desk.com, which is a SaaS company that is owned by Salesforce.com now, that is leveraging Redshift to provide more analytical capabilities to their end customers. And for the last 2 years, as Andy pointed in the keynote today, Redshift has been the fastest growing AWS service until Aurora uprooted it a bit ago. And with all your help, I'm hoping we can grab that title back by next year. So taking a step back, I'm going to go over a little bit of detail around Redshift's architecture. So we talked about Redshift being an MPP-based engine. So we have a leader node through which you access the cluster if you will. And the leader node stores the metadata for all your database objects. It generates an optimized query plan and pushes code into the compute nodes so that the queries can be executed all in parallel. The compute node themselves store the data locally in columnar format and processes a variety of operations in a distributed and parallelized manner for fast performance. You can start with Redshift at 25 cents an hour for 160 gigabytes, and you can scale it up to 2 petabytes of compressed data. And we have customers running multiple petabytes today on Redshift. So some of the key features and their benefits. Redshift is fast because of a variety of reasons. It uses columnar storage, which means you perform dramatically less I/O than row stores, which fetch a lot of data but discard significant percentage of it that is not required. Redshift does automatic data compression, which again means faster I/O performance, but also lower storage costs. So we typically see customers getting an average of 4 times compression ratio with Redshift. So if you're bringing a 100 terabyte data warehouse, it could as well be 25, 30 terabytes on Redshift. We use direct attached storage, and the block sizes that Redshift uses is a megabyte, which is pretty large compared to transactional systems. And this enables very fast scan rates. So with Redshift, you can get up to 4 gigabytes per second per node of scan rate. Given data warehousing is very read intensive, scan performance is pretty important. Redshift also uses zone maps for fast performance. So the way zone maps work is each column within a table gets an MB of several MB of contiguous blocks, and each block, as we discussed, is a megabyte in size. And we store the min-max value of each block in memory, so that for a sorted data set, when you're executing a query, we fetch the minimal number of blocks possible to give you answers very quickly. We'll talk a little bit more about zone maps and sort keys in a bit. Just the next slide. So here is an example of zone maps and how sort keys play a significant role in Redshift. So as you think about getting started with Redshift, understanding sort keys and what do they mean in your environment is very important. So here is an example of a table with unsorted data. So it's a date field, and each block, as you can see here, has a min and max value, but there's a significant amount of overlap because the data is not sorted. So if you perform a query where you're selecting count star from this table where you're trying to get data for a specific date. And this sort of a query will hit 3 of the 4 blocks. So we have to read 3 of the 4 blocks to process this query, because 9th June falls in the first block, second block, as well as the fourth block. If you have a sorted data set, and you can see here that there's no overlap between the ranges in any of these blocks, it'll be just one block. And this is a simplistic example, but the difference in the execution times can be thought through in terms of complexity. So the first data model has an order of n complexity. The second data model has an order of 1 complexity. So if you have 1 million blocks, the second query will return results significantly faster than the first one. And we do also have an intermediary stage there with what we call as interleaved sort keys that enable you to get performance that's somewhere in between. So there's some trade-offs with using interleaved sort keys. We have an advanced session tomorrow about Redshift. I encourage you to attend if you want to learn more about it. Redshift is also fast because of the way the various operations that are needed for processing queries, for maintenance of the clusters. So all of these happen in a parallel and distributed manner. So queries happen parallelly and they're distributed. Loads, unloads, backups, restoration, resize, all of these operations are parallel, which means the performance of your cluster across these operations grows linearly as you add more nodes. Distribution keys is another concept that you want to understand before getting started with Redshift. So here is a simple example where we have a table with a set of rows. And typically, you want to load data into Redshift through S3. There are other mechanisms if you're using DynamoDB and other services. But by far, S3 tends to be the most common source for customers to load data into Redshift. And when you're loading data through the copy command, each core within a compute node picks up a file in parallel and starts loading that data. So if you have 3 compute nodes in this example, let's say each compute node has 30 cores, so you have 90 cores that is available for processing loads in parallel. And each core will go to S3 and pick up a file. So we encourage you to have multiples of 90 in this particular case, or multiples of the number of cores, so that the data load happens very quickly. So once the data gets loaded, each of the data points that you have will need to find a home based on how you're distributing the data. So one way to distribute the data is evenly. So in this particular case, it's just a round-robin way of distributing the data. So we have 2 other ways through which you can distribute data. You can have all of this data sit in all the compute nodes instead of distributing it. So you have the exact same copy of the data in all the nodes. This is typically the option for smaller dimension tables where you perform lookups. So the idea would be any join that you're performing, you would want to aim for having the join performed locally so that there's no chattiness across the nodes. The other way to distribute data is through a key. So if you have a large fact table and a large dimension table that you're joining, you would want to distribute the data using that particular key so that all of your joins between those tables get served within the context of a compute node, and there's not much interaction between the nodes at that point. There'll be more discussion around it in the advanced session. My idea was to just give you a taste of the things that you need to keep in mind before you get started with Redshift. Sort and distribution keys are very important, is the bottom line. Redshift is also fast because we run on optimized hardware that is optimized for I/O-intensive workloads. So we talked about the 4 GB per second scan rate per node. We have enhanced networking that enables 1 million packets per second of retrieval. You have the choice to pick between SSD nodes and magnetic storage. SSD storage offers 10 to 15 times more performance than magnetic storage, but it's 5 times more expensive. So depending on your cost performance requirements, you would pick one versus the other. We also have a very easy way for customers to migrate from one generation of hardware to another generation. One recent example is we launched support for DS2 instance type, which is a next generation hard disk based platform, and it provides 2 times more memory, 2 times more compute capacity, 1.5 times more bandwidth as a previous generation of the instance family at the exact same cost. So as we get more efficiencies in the hardware, we pass that along to customers across all the services, as you may be familiar with the AWS pricing philosophy. That takes us to the cost aspect. Redshift, as we talked about, is very inexpensive compared to a lot of other options in the market. So you can process data at less than $1,000 per terabyte per year, when most of the other options in the market costs anywhere between 10 to 25 times, in some cases 50 times more. We don't charge for the leader node. Pricing is pretty simple. We have 2 different pricing types. You can choose on-demand or you can choose RIs if you're familiar with how RIs work in the EC2 world. We talked a little bit about the managed nature of Redshift. So one of the things that is very appealing, that customers say is very appealing to them, is Redshift does continuous and incremental backups. So you have, whenever you write data into Redshift, copies of that data are propagated to other nodes in a synchronous manner for higher data durability. Data is also backed up into S3 in a continuous manner. And incremental is a very important concept. So if you have a terabyte large data warehouse that you have just backed up, and you loaded 100 gigs of data, the next backup will only pick the delta of 100 gigs and not the entire 1.1 terabytes. I think probably the understated feature here is streaming restore. This is something that a lot of our customers say they're pleasantly surprised by after we talk through it. So streaming restore enables you to create a cluster from your backup, even if it's no matter the size. It could be 100 terabytes, it could be a petabyte. You can start querying your restored cluster within under 3 minutes. You can do writes on it, you can do reads on it. The data behind the scenes gets streamed from S3, and the queries that you're performing on the cluster will determine the priority of the blocks that are being fetched. In most cases in data warehousing, 80 to 90% of the data is not frequently accessed. So the 10% of the data is loaded first and the rest later. That enables quicker processing, quicker time to query for restores. Redshift is also fault tolerant. So we monitor the health of each node within your Redshift clusters, and detect failures and take remedial actions based on that. So Redshift can tolerate multiple disk failures, multiple node failures, and whenever the failure occurs, we detect it and then we provision a replacement. And the replacement process works very similar to the streaming restore process, where the replacement node is provisioned with the bare minimum schema that is necessary to continue the queries. And then the node gets hydrated behind the scenes from the copies of the data that we have in other nodes. It's very easy to set up disaster recovery with Redshift. With a few clicks on the management console, you can say, here is my source region, and here are my backups. Move those backups to a destination region and keep them in sync. And the restoration from the backups in the other region happen in a streaming restore manner, so it's very fast. Security is an aspect that I'm sure is near and dear to most of you here. And from the get-go, Redshift has been designed with enterprise-level security in mind. So we have end-to-end encryption, starting with loading the data in an encrypted manner in S3, loading that data from S3 into Redshift in an encrypted manner over transit. You have a variety of encryption options available to you. You can use Cloud HSM, you can use on-premise HSM to secure the data at rest and have control over it. There are several levels of audit logging available so that you can understand who is executing queries, what roles do they have, what times are those queries executed, who is logging in, etc. We also have several compliance initiatives that we have been through, and notably BAA, which is the healthcare specific compliance requirement, FedRAMP, which is the federal government standard, which is pretty stringent. So all of these are enterprise-level compliance requirements that Redshift satisfies. So one of the interesting aspects that is made possible in the cloud-based environment is the ability for us to do continuous deployments. As I'm sure a lot of you strive to achieve on the service and the product side, we strive to achieve continuous deployments as well. So which means you have code coming in, new features coming in, reliability improvements, security improvements, all of those streaming in a very continuous manner. We actually have patches coming every 2 weeks for the most part. So we released over 100 new features in the last 2+ years that Redshift has been around. And most on-premise data warehousing systems, you have to wait for 6 months, 1 year to get new features. Redshift provides you a lot of analytical horsepower. It enables you to do a lot of interesting things around data science. So we have approximate functions that enable you to do count distinct sort of queries extremely quickly with some margin of error, which is typically in the range of 1 to 2%. We recently released user-defined functions, which makes thousands of Python functions available to you. You can define your own functions. You can bring your own libraries, call those functions from SQL for doing advanced analytical functions, as well as data-related functions, as well as optimization research or so operations research or optimization related functions. So Python makes all of these available, and with the support for the user-defined functions, you can take advantage of them. We talked a little bit about machine learning and the ability to define predictive analytics models and use Redshift as a data source and run these models against it through the machine learning service. You also can use a variety of partner tools. So we work with SAS pretty closely. So if you're using advanced statistical technologies like SAS, you can take advantage of the processing power of Redshift and then feed the results into SAS for advanced analytics. You can do the same with R as well. So we have a fairly large ecosystem, and we understand that in the warehousing world, a lot of you probably are migrating from other systems. You have existing investments in BI tooling and ETL tooling that we respect. So we work with a lot of data integration partners. We work with a lot of BI partners. In addition, there are a lot of system integrators that we work with to enable you to either migrate or get started with Redshift very quickly. So we follow a service-oriented architecture across AWS. So we have multiple services that you can use as building blocks to put together any solution that you desire in the analytics side. So there are a variety of services. We talked a little bit about machine learning. You can plug cloud search into Redshift for doing text-related search and other analytics with Redshift. So we have Kinesis and now Firehose. So with Firehose, you can set Redshift as one of the destinations. All you have to do is define a throughput that you require for your stream, and then specify a copy command that can be executed by Redshift on a periodical basis, typically every 5 minutes, so that you are able to do analytics in a near real-time manner. So a few use cases and how customers are leveraging these features and functionality to enable interesting things in their analytics environments. The first one is sort of a hypothetical use case. So we looked at how much it would cost for somebody to stream the entire Twitter Firehose and analyze it through the various building blocks we have within our analytics portfolio. So you have the Kinesis stream that can, I think Twitter has around, at least a year ago, it used to generate around 500 million tweets a day. Let's say you stream those through Kinesis, move that into Redshift or S3, depending on where you want to persist them. So different costs for each of these services. And it comes to less than $3 an hour to stream the entire Twitter Firehose and perform analytics on it using these various building blocks, less than how much it would cost you for a Starbucks coffee. So the idea here is you can perform really powerful analytics with Redshift and Kinesis and the other services that you have at a very cost-effective price point. You can scale these services as you need. You have RIs through which you can get more discounts if you decide that's the path that you want to go for a year more or 3 years. Another interesting example is Amazon.com. So Amazon.com, as you know, is one of the highly trafficked website in the world. So we get around 150 million visits on a monthly basis. So in an e-commerce sort of a use case, you want to get this data, you want to get the clickstream data and analyze purchase patterns and behaviors. Who is purchasing what products, who is moving through the cart and not purchasing eventually, and then go back into the reasons of why that's happening. This is a big data workload. It's a petabyte scale. They're generating 2 terabytes of clickstream data a day and growing at around 67% year over year. So the largest table is 400 terabytes. That's a significantly large footprint. So their legacy data warehouse solution, which was based on Oracle RAC, through that they were able to do scans of scan of 1 week of data per hour. So in an hour, they were able to process 1 week worth of data. And that was not enough for them. They wanted to do more longitudinal analysis. And there's also space and storage constraints if you're using RAC, the number of nodes that you can have there. So they moved to a Hadoop-based system, and that enabled them to grow, to do this much faster. So they were able to query 1 month of data in an hour. With Redshift, which is when they, 2 years ago that they started looking at this project, which was when Redshift was released, they were able to query 15 months of data in under 14 minutes. So they went from querying 1 week of data to 1 month of data to 15 months in less than 15 minutes. They are able to load 5 billion rows in under 10 minutes and join and perform really complex joins across huge data sets and tables. In this particular case, one of the queries that used to take 3 days started taking 2 hours in Redshift. And their load pipeline for ETL became significantly faster as well. So it's a fairly large footprint. They have lots of clusters and lots of nodes across lots of different groups within Amazon that is now using Redshift. And all of this they're able to do with 2 DBAs. And I think that's a significant part of this equation. It's just not the DBA aspect. There's also the data engineering aspect, and data engineers typically spend a ton of time trying to figure out the ETL process, trying to recover from failures if jobs fail. And so that is also another significant investment in time. All of that reduced considerably with Redshift. Another example that we talked a little bit about in the keynote is NTT Docomo. So they are they're probably the largest telecom company in Japan, and generate petabytes of data corresponding to their cell phone towers and mobile usage within the company. And they work on a hybrid sort of a model where all of this data gets generated in their on-premises environment. Then they move this data to Redshift and AWS to analyze it. So this is another use case that had very stringent security requirements to move the data. So the various components within Redshift that enable the security requirements to be satisfied include some of the things that we already talked about, the encryption at rest aspects with the various levels of key management available. So Redshift runs you can run Redshift in VPC and define your own subnets and networking topologies to secure your data. You can audit all your SQL queries and user logins. So all of this is made possible and done in a very fast time frame. Their migration took I think a few weeks to get it all going. So at this point, they believe that cloud is at least as secure or more secure than the environment that they've been running in. So another interesting use case, and we somehow tend to see these in Japan. So there's a sushi chain with 380 odd stores in Japan. They use their plates, the sushi plates, as IoT devices. They plug them in onto the plates. The plates move across the store, and of course, people order and consume sushis. and they stream the data related to the food consumption through Kinesis, and then that data finds its way into Redshift within 5 minutes or so. So this sort of architecture enables them to combine their inventory information with consumption information so that they can better understand their supply chain behavior, control costs, and bring in more efficiencies. So one of the interesting things around big data is it tends to be thought as a more batch-oriented workflow, and immediate operational intelligence is something that we see. We hear customers are saying extremely difficult or hard to do. So with services like Kinesis and the ability to move that data very quickly into Redshift enables you to do near real-time analysis. It's not real-time, but it's near real-time. You can mix and match environments like Entity Docomo, where you can run your keep running your on-premise environments and move your analytics into the cloud to unleash value. So overall, if there's one thought that I want you to take from this session is we continuously strive so that you spend less and less time on your databases and more time on your data. I think we have achieved that quite a bit over the last 2 years, and we have more ways to go. Happy that you came here and listened to this, and I'm going to turn it on to Nam and have him talk about how Redshift fits into their analytical platform.
Thanks so much, Pavan. So my name is Nam. I'm an engineering manager at RetailMeNot. Lesser known, my sisters used to call me Pepperoni Nipples when I was growing up. To be honest, I feel like that nickname applies to a lot more people in this room than they realize. So who is RetailMeNot? RetailMeNot is a digital offers destination that connects consumers to savings. We have 50,000 stores. We typically have 500,000 coupons on at all time, and we connect every year to 500 million users. This is our overall data flow. It kind of starts at the top with visits. And people come to your site, they click around. That's kind of the presentation platform's activity section. And we track everything from impressions to your favorites, to your likes, to your dislikes. When you come to our site and find something that you like, you'll typically go to like a Kohl's or a Macy's. Sports stores for me, I personally like triathlon equipment, but whenever I click and make a purchase, it goes to financials, all of that gets tracked. Typically, we also record a lot of third-party data. So Google Web Toolkit for SEO, ExactTarget for email tracking. We do a lot of demographics tracking as well as IP location tracking. And this data processing box here is probably the majority of what we're going to be talking about. This produces a lot of interesting analytics for our content operations, marketing, and statistics that we then feed back into our presentation activities. Content operations, obviously, they're the ones in charge of making sure the coupons and presentation of information on our website meets our customers' needs, gives them the best experience. Marketing operations, of course, is in charge of making sure that money spent on marketing goes to the right channels, and all of that is based on information that we do. They decide how much money we spend on SEO marketing, email campaigns, TV ads, stuff like that, which in turns lead to more visits, kind of completing the cycle of coupon activity at RetailMeNot. So our data is typically in the hundreds of terabytes now. I would say that's kind of the new norm of information. Back when I first started processing with data, I think I had systems that were in the tens of gigs and hundreds of gigs, and I thought that was big data. But typically these days, if you're not in the terabytes, you probably could just look under your couch cushion and find a terabyte of data somewhere. What's more interesting for us is kind of our data growth. We started out with our data warehousing strategy or project back in 2012, and I think we had 500 gigs of data starting then. Every year we had growth over 100%, and that created a lot of problems for us using our, at the time, legacy warehousing strategy, which I think was basically taking physical hardware strategies using legacy data warehousing systems and kind of just implementing them in the cloud. the legacy. So I think a lot of people in this room, hopefully you guys can relate to different sources of data for warehousing. We have a lot of operational data stores. These are our MySQL databases that house user information, coupon information, things that get presented to the site. We have a lot of log data. This is web logs, beacon event logs. This is probably the larger collection of data that we have. And we also have the third-party data that we collected, as mentioned before. In the legacy world, we basically took this data and shoved it straight into our data warehouse. And it was a single monolithic system, single point of failure. And for us, this happened to be Vertica. You know, I think a single monolithic data warehouse is kind of moving towards the wayside. I think a lot of people are realizing that these systems are very, very hard to maintain. And Redshift has definitely given us a strategy to kind of escape this paradigm. From the data warehouse, you know, we obviously produce a lot of deliverables, reports to various people. We did A/B testing for our websites in our Vertica system. And we also produce statistics for content presentation. And this produced a lot of pain points for us. First one is firefights. I don't know, could I get a raise of hands for anyone that's ever been on call for support for database systems? Yeah, firefights kind of suck, especially if you've ever dealt with a multi-parallel clustered database system. You know, you have the opportunity for disk drives on any of the nodes to fail. If a node fails, you get called in the middle of the night. It's very time-consuming to fix, especially when you deal with some of these very specific database systems where you have a lot of steps in order to go through recovery and redistributing data and kind of recovery of data. That's always a pain point. The next problem that we had in the central monolithic system were traffic jams. I don't know how many people have actually queried database systems, but if you're in a big shared clustered environment, you may start to run a query. The query just sits there, kind of waiting. Nothing's going on. It's not your fault. Select top one. Just sitting waiting around. And you know, in some of these cases, there are the analysts that you can blame. Joe, who has the 1,000-line SQL statement with a whole bunch of cases aggregating on, you know, the join of a case statement with the case statement on a join on another table, and it's just ridiculous. But a lot of times this can also happen just with too many people on the system. And you know, in the past, we didn't really have a strategy for dealing with traffic jams other than killing people's queries or telling people that they couldn't run their queries on the system. And this is obviously problematic, bad PR for your data team. You know, you want to try to avoid that. Processing windows. When we first started back in 2012, you know, it's really easy to process 500 gigs of data in an hour. Start our processing typically around 2 a.m. You know, we finished by 3, turned into 5, turned into 7, turned into noon, and then someone was like, hey, come on, you guys, you got to do better than this. It's starting to become a problem. Our consumers need their data first thing in the morning, and you got to get it done somehow in some way. The other thing was scaling. So in these systems, adding more nodes, replacing instance types, these kinds of things, very manual. It'd be great if there was some kind of managed database service where you just do a couple button clicks and kind of solve this problem. You know, we had to typically do it through our stage environments, test environments, dev environments, and production environments. And it was just a lot of extra work for not a lot of productivity gains. So how did we kind of solve this? Well, I would classify it as adopting more cloud strategies for data warehousing. And overall, we didn't really have to change too much. So we still have the same source DBs, same log data, all of that stuff didn't really change. One of the big changes for us was that we started loading everything into S3. If you're going to use Redshift, the fastest way to load data into Redshift is from S3. We didn't really have a lot of DynamoDB, that's another option, but S3 gives you a lot of flexibility, and I'm sure there's lots of talks about how awesome S3 is. They're true. Next is Amazon Redshift instances. Notice how here there's not a single Redshift cluster. I think for us, Redshift does solve a lot of the administration problems by itself, but if we were to have had a single Redshift cluster, I don't think it would have solved a lot of the concurrency issues or resource contention issues that we had. I'll dive into the details of why we have so many clusters in a moment. We still have the same number of deliverables. We essentially replaced the sources of data with data coming out of Redshift. Still did reporting, still did A/B testing, content presentation, but we were able, after doing this migration, start to do other types of things because we had some additional time on our hands after we were able to perform this migration to Redshift. So the on-demand breakdown. I would say if there was anything that you guys were to take out of this meeting, aside from the pepperoni nipples comment, it would be this slide. So from S3, the way that we use Redshift, the first class of clusters that we have are only as needed. You know, we have a lot of analysts. They don't like to learn different languages and things like that. They're very, I guess, fixed on their SQL, and with Vertica and SQL 99 compliant SQL, they were able to use Redshift and spin up on-demand clusters for them to do kind of ad hoc analysis. These clusters typically live, only for a day, and they shut down and you never need them again. So this was a very flexible way for us to expose information to analysts for stuff that they had never seen before. They would run crazy queries that you typically don't want them running on your production system without any impact to any other person in the organization. The next class of clusters we have are ephemeral processing clusters. These are pretty medium-sized clusters. They generally are only on 1 to 3 hours a day, and they kick off early in the morning, 2 a.m.-ish. This was actually probably the biggest shift for us. We basically split out a lot of the systems and data processing and aggregations from our central cluster and said, how many of these actually depend on each other? And for things that don't depend on each other, we're able to scale them out horizontally using these ephemeral processing clusters. One of the nice things about Redshift is that it maintains state when it shuts down. So every time you bring it up, it has all the data exactly as it was from the prior state or from the prior day of processing, and you can just pick up where you left off. So this was actually a huge benefit for us. The next class is business hours. Most of your analysts, I hope, do not work 24/7. And when we started implementing some of these business hour clusters, we got some resistance for people that were saying, hey, I need access to my data on Saturday at 10 p.m. And I'm like, well, we can give you a way to do it, but we'd like to shut it down over the weekends to save money. And we're like, you really don't have to work on Saturday at 10 p.m. most of the time. So they begrudgingly accepted, and they seem to be a lot happier on Mondays when they come in. I don't know. It's just my interaction with some of these guys. The next class of clusters are the always-up clusters. These clusters typically are what our Tableaus connect to. External customers, if they have reports that they need to hit, they kind of connect to these. We're also an international company. So we have internal customers in the UK, France. They will hit these always-up clusters. And the workflow here is that the ephemeral processing will churn on data, produce aggregates, spit it out to S3, and the always-up clusters will then consume data when it becomes available. They're usually only 1 to 2 terabytes of clusters, sized clusters, because they don't need all of that raw data. And usually, if you're turning on all that raw data for your reports are really slow. We like to have slightly faster reports. So what does this mean for the data team overall? Shifting to Redshift, as Pavan mentioned, Redshift is data as a service. Our administration and firefights have become a lot easier. I typically look like this. Notice that guy's not wearing any pants. When I get called in the middle of the night, I'm also not wearing pants. But the time that I spend is more just logging in, checking to make sure the status. I'm not actively doing, migration or bringing up of instances and re-adding stuff to nodes. Like all of that is handled by AWS. Most recently, I think we had a cluster go down probably last month for half an hour in the middle of the night. I think we just woke up in the middle and the next day and we're like, did you guys actually do anything? No? Well, okay, it's up. So it was a lot easier for us after we switched over to Redshift. Scaling the number of clusters is a lot easier. I mean, if you guys have ever worked with RDS, scaling number of Redshift clusters is basically the same as scaling the number of RDS instances. And once again, this provides us the ability to scale our data processing horizontally, greatly expanding the number of jobs that we can do in a single night. Scaling the size of the clusters is just as easy as doing it with RDS as well. You basically click, select the instance type, select the number. Redshift goes into a read-only mode state. Probably for us, it typically takes about 5-ish hours for 30 terabyte to 100 terabyte cluster sizes. And it's more based on the amount of disk space you use. So if you're using 100% of disk space of a cluster, it'll probably take a little bit longer. But when you're right around the sweet spot of 50% disk space usage, it'll probably take about 5 hours. The cluster is in read-only. Once it's done resizing, it automatically switches to the new cluster instance sizes and instance types, does all the rebalancing behind the scenes for you, and you really didn't have to do very much work or spend time to babysit. Processing windows. Now we seem to just have so much more time, and our analysts have actually started kind of spinning up their own Redshift clusters to do their own processing. My favorite analyst basically giggled when I told him about this, and he's been a huge adopter, and they each get their own little data ecosystems where they can process data completely untouched by other teams and other systems, and then redistribute it throughout the organization once they unload it back to S3. Lessons learned. These are my Homer Simpson moments that we kind of experienced during our migration. I wasn't allowed to put a Homer Simpson picture on here. Automated cluster shutdown. A lot of these can be very, very large clusters. I think one of ours is, $350,000 a year, which for some of you guys may not be a lot of money. For some of you guys, it is a lot of money. If you leave these clusters up, I think we had one cluster that was up for a month and nobody was really using it and we just kind of accidentally left it on. I would highly recommend having an automated shutdown process, like every night. Having a cluster shut down, especially for data warehousing when nobody's using it, and starting one up again is a lot easier to do than trying to get a rebate back from Amazon for a cluster that's been up for an extra month. I don't think they offer that feature. Sort and distribution keys. Pavan mentioned this before. It's hugely important, I think, to get the sort and distribution keys correct, especially for joins across multiple data sets. If you don't, it starts to do chatter and cross-communication between all of the clustered nodes, and our queries typically, in the worst case, took like 3 to 5 hours. After fixing the sort keys and things like that, it went down to 15 minutes. I think query optimization and performance optimization on the databases is very, very well worthwhile. Reserved instances. I think that with RDS and EC2 and other types of instances, there's a lot of options, and sometimes because of the size of those instances, the benefit for reserved instances aren't as pronounced. Redshift only has 2 instance types, or 4 instance types. So I think it's a lot more compelling to be able, and a lot easier, to select the instance type that you're going to be working with Redshift much earlier. And since you're probably dealing with multi-terabyte systems, the cost benefit is going to be a lot greater. So I think for us, choosing reserved instances early on in the process would have been very well worthwhile for us. And the last one is automated versus manual backups. So with Redshift, they definitely have the automated backups similar to RDS. You can pick the number of days for the retention period, but the tricky part is that when the cluster goes down, so do the automated backups. So automated backups are really good for forking your data or kind of spinning off another or recovering from a prior state while your system is up. But if your system goes down and your automated backups disappear, you're kind of SOL. So definitely always do manual backups on a regular basis. Otherwise, you kind of might be wishing you had some place to restore from. Benefits to the business. So obviously the data team loves Redshift. I think unless it benefits the business in some way, shape, or form, it's really just a data toy. For us, instance type alone We had Vertica in our monolithic system on EC2s with multiple terabytes of EBS volumes attached to them. Switching over to Redshift netted roughly a 50% cost reduction in EC2 instance types alone. The other benefit of Redshift is the licensing cost. So on these kind of legacy data warehousing systems, you're charged either by cores on your instance types or by storage. With Redshift, that's already baked into the cost, and it's a very compelling reason for moving over to Redshift. 50% reduction time on administration. I would say this is more database administration. You still have to do kind of the query optimization, but database as a service, I've loved it. I don't know if I could ever go back to being a DBA. And then internal customers. So I think the number one measure of success for a project in your company is how adopted it becomes. Typically, we had the BA system and the financial teams were primary customers for the data warehouse team at RetailMeNot. We basically doubled those when I made these slides. It's gone up even more since then. People are just, once they see how easy it is to get access to information using this system without impacting other teams or production systems, they jump on it right away. I mean, information is quickly becoming the lifeblood of a lot of companies, and quick and easy access to information is hugely beneficial for the organization. With that, I think I'd like to open it up to Q&A.